Welcome back everybody to Simple Harmonic Motion. Today we are doing a few multiple choice questions, kind of as a review for the whole unit. So hope you guys enjoy. Alright, we got a little bit of a tough one for the first one. Let's see here. A simple pendulum has a period of t on Earth. What is the period of t prime of this same pendulum on the moon, where the acceleration due to gravity is 1/6 that of the Earth? As always, pause the video to see if you can figure it out for yourself. But here I go. First, let's look at the period of the formula for period. 2 pi square root of the length of the string divided by gravity. Only thing that's changing here is gravity. We're going to the moon. What we know is gravity is 1/6 that of Earth. It's going to be a lot less. So we can see that gravity is in the denominator side. So that means this period is going to be affected in the denominator side. And it's going to be 1/6, but we also need to remember that this is a square root, so we have to square root this over here. Okay, so we can see that this period is going to be affected. If we kind of change things around, it's going to be t square root of 6 square root of 1. Sorry about that. Kind of flipped it because it was on the denominator here. Okay, and then we can see that it's going to be c over here. Okay. Because this simplifies. Square root of 1 is just 1, so it's just t square root of 6. Okay, so it is going to be longer to take the swings. Alright, moving on. Conceptual example number 14. A pendulum-driven clock located on the Earth is set into motion by releasing its 10-meter long simple pendulum from a maximum angle of less than 10 degrees to the vertical. At what approximate time will the pendulum have fallen into a perfectly vertical orientation? Okay, so again, we're going to look at the formula for period. Period is equal to 2 pi square root of length divided by gravity. But we know what length and gravity is. The length is 10 meters long. And gravity is 10 meters per second squared. We're assuming we're on Earth. So we can find that this is going to just be equal to 1. So we can see that period is equal to 2 pi. However, it's not asking us for what the period is. It's asking at what approximate time will the pendulum fall in to the perfectly vertical orientation. So how long does it go from here to here? And we know a period is all the way here and all the way back. So this part here is only 1/4 of that. So we could do 2 pi divided by 4. And this would be pi over 2 is how long it's going to take. D. Alright, moving on. A light spring with a spring constant of 10 Newton per meter is attached to a mass. The mass is pulled down and released and exhibits simple harmonic motion with a period of 0.2 pi. The mass is blank. Okay, similar thing, we're going to look at the formula for a spring that's oscillating. 2 pi square root of mass divided by k. Okay, so let's plug some things in. Period is period is given to us 0.2 pi is equal to 2 pi square root of mass, that's what we're looking for, divided by k, which is 10. We can cancel out pi because it's on both sides, and then let's do some math here. 0.2 divided by 2, square that, and times 10, and then we get 0.1 kilograms. Alright, moving on. Which of the following graphs describes simple periodic motion with amplitude 2 centimeters and angular frequency 2 radians per second? Okay, so first, let's look at this first part. Amplitude of 2 centimeters. So A checks that, it's 2 centimeters, the amplitude. B checks that, 2 centimeters. C checks that, 2 centimeters. D does not check that, so it can't be D. And E does not check that because it can't be E, it's 1 each. So angular frequency of 2 radians per second. That's a little bit hard to know, but we do know that angular frequency is equal to 2 pi divided by t. So this can help us find the period, which might help us as well. So angular frequency is 2 pi divide by period, and now let's find what period is. Okay, I'll cancel this out, and we can see that period is equal to pi, which is around 3.14. Okay, so can't be from here to here, that would be the period, but that looks like it's less than 2, so can't be that. This one, okay, this looks like it's pretty close to 3.1, so maybe. This one here, definitely not. And nope. So it would have to be B. Okay, hope that made sense. Watch it again. I might have went a little too quick for that one, so watch it again if it was a little bit confusing. Okay, moving on. Oh, actually, that's it. All right, well, thanks for watching, everybody. I hope to see you with the next unit, so see you with that. Bye, guys.